Okay, this is a few homework problems. I'll do a few of the odd ones from section 1.1. Problem number 1 says graph the equations and find the x and y intercepts and the slope. First problem is y equals negative 3x plus 2. The slope, if it's solved for y, the slope is the number before the x, so the slope is negative 3. The y-intercept is 0, 2. And to get the x-intercept, you can put 0 in for y and solve it for x. Or I'm going to go ahead and use the Excel sheet to get you used to this. So it's already solved for y. It's y equals negative 3x plus 2. So on the linear sheet, put a negative 3 in here for the a. See, here's your format right here. So negative 3 is the a and 2 is the b. And then once you get that in there, clear off these data points because we don't want to show these data points. So clear those. Click the yes button to clear those. And then down here, we can set the viewing window if you like. Right here, change. Use these cells to change the viewing window. So I don't know if you'd like to see it from negative 5 to 5 or wherever you like to see it. But there's the graph of that equation. Again, up here, it tells you the slope is negative 3, which means it's falling 3, running 1. Here's the y-intercept. It's actually the coordinate 0, 2, and it gives you the 2 right there, but there it is as a coordinate 0, 2. And the x-intercept is 0.67, 0. So the x-intercept hits right here. Here it is. Like here's 1, and here's about 0.67, and right here's the y-intercept at about 2. Okay, let's go ahead on to problem 3. And problem 3 says this one, 3y minus 4x equals 1. Same stuff, finding the x and y intercepts and the slope. 3y minus 4x equals 1. Now that one, we're going to have to solve it for y. So here it is, 3y minus 4x equals 1. Need to solve it for y. We add 4x to both sides, and you get 3y equals 4x plus 1. I just added 4x to both sides. Then divide by 3. And you get y equals 4/3 x plus 1/3. I divided everything by 3. The 3 divided by 3 right here will divide out. So y equals 4/3 x, or 4x over 3. Either way, the coefficient of the a is 4/3 and the b is 1/3. So your slope is 4/3 and your y-intercept is 0, 1/3. And again, you could put those into Excel, 4/3 and 1/3. So 4/3 right here and 1/3 right here. And there's the graph of that thing. You can see it's going up. It's rising 4 every run of 3. It just wrote it as a decimal right there. But that's the slope. That's the y-intercept. You can change your viewing window down here. X-intercepts and y-intercepts are calculated for you right here. If you wanted to get a y value for an x value, just type it in. If you want to get an x value for a particular y value, just type it in, and it will substitute those into the equation. So anyway, that's the graph of 3. Let's take a look at 5. 5 is, see, it's already solved for y, so it's as easy as number 1. The a, your slope is 1, because it's 1x right there, and your b is 3. So a is 1, b is 3. That's all you do. On this one, 7, the slope is 1/2, because it's 1x over 2, or 1/2 x. So the a is 1/2, your b is 2/3. Put those in there, and you'll get everything you need. 8, see, that'd be negative 1/3 and 4/3. 9, let's take a look at 9 here. On 9, it says this equation right here where n is the dependent variable. Now, since n is the dependent variable, n is treated as the y variable. So we got to solve it for y. So in this case, you solve it for n. Subtract the 4t from both sides, you get 5n equals negative 4t plus 100. Then divide through by 5, and you get n equals negative 4/5 t. Negative 4t over 5, so there's your slope, negative 4/5. And then that's also divided by the 5 right here, too. Everything's divided by the 5, divided by the number beside the n. n equals negative 4/5 t plus 100/5. That's the same as 20 right there. So we just put those in, negative 4/5, and let's do that. Negative 4/5. And I think the other one was 100/5, but that's the same as 20. When you type it in, it gives you 20 anyway. There's your x-intercept, there's your y-intercept, there's your slope right there, and there's your graph. Looks something like that. Okay, let's take a look at 11. 11 says mathematical model that approximates the purchasing power of the dollar is given by this equation right here. It's a linear equation. Where y represents the purchasing power of the dollar, t equals 6 is 1986. And hint here, if t equals 6 is 1986, then t equals 0, which is 6 years earlier, must be 1980. That helps to know that because that will tell you your slope, your y-intercept. So anyway, this model has a domain going from 6 to 13. This just means that we should get realistic answers for the purchasing power when t goes from 6 to 13. So part A says for this equation, what is the slope? What does it tell you? Well, here's the slope, negative 0.03. Negative means it's going down. So the purchasing power of the dollar goes down by 3 cents every year. Why every year? Because this is negative 0.03 over 1. And you're running along the time axis. So you're running 1 every time the purchasing power goes down 3 cents. Purchasing power drops 3 cents every year is what the slope means. What does the y-intercept mean, part B? Well, here's the y part of the y-intercept, 1.12. The x part is 0. The x here tells you the amount of time that's gone by. So this means that in year 0, which is 1980, in 1980 the purchasing power of the dollar was $1.12. So a dollar was worth more back in 1980. C says use a model to determine when the purchasing power of the dollar will be 50 cents, 10 cents, and 0 cents. Well, we would, if we were doing this by hand, we would put in 0.5 for 50 cents or 0.50, either way you like. Put that in for y and solve it. Or you can use the Excel sheet here to do it. So let's do that in a second. The slope was negative 0.03 and the y-intercept was $1.12. And then when will the purchasing power be 50 cents? Well, you just put 50 cents or 0.5 in here for the y value, and there's your calculated x value right there. So it will be worth 50 cents in 20.67 years after 1980. It will be worth 10 cents, so I just put in 0.1. It will be worth 10 cents 34 years after 1980, and it will be worth nothing 37.33 years after 1980. And by the way, that is your x-intercept up here, 37.33, 0. So according to this model, 37.33 years after 1980, which would be the year 2017, a dollar would be worth nothing. Now that's what this model predicts, but again it says here on this problem that this has a domain from 6 to 13. In other words, it gives realistic answers from 1986 up to 1993. So when we're doing long-term extrapolation here, and we get unrealistic answers. So that's just about it. This is the same type of thing on 12, where you have the slope. This is the life expectancy. Here's the slope. It's going up 0.29 years every year. Life expectancy is going up by 0.29 of a year every year. And then this is the y-intercept. This means that according to this model, at t equals 0 in 1950, the expected life expectancy was 65.36. And so it asks those type of things, and you could put those in there to get those answers. And then finally, on 13, what is the slope, x-intercept, and everything for this equation? Well, on this one, let me copy this here a second. You will need to solve that for y, which is a little bit of work here. So to do that, to solve it for y, the first thing you might want to do is multiply the entire equation by 3 to eliminate that denominator there. So if you multiply everything by 3, we would get, let me just put this here. So multiplying this whole thing by 3, we would get y minus 4. And then multiplying the negative x by 3, we would have minus 3x. And then multiplying the negative 1 by 3, we would have a minus 3. Equals, go across to the other side. This has to be multiplied by the 3 as well. 3 times x plus y. Now just distribute across. We have y minus 4 minus 3x minus 3 equals 3x plus 3y. Now we're solving this for y so we can get the slope and that sort of thing. So what I'm saying here is that I want to get all the y's to the left. So I'm going to subtract 3y. That will get rid of this 3y, and y, 1y, that's what we have here, 1y minus 3y. See, I'm subtracting the 3y from both sides, is what I'm doing. Same, minus 3y, and over here, I'm minusing 3y, subtracting 3y too. And that would give me 1y minus 3y is negative 2y. And let's write down the rest of the stuff we have here. Minus 4, well, I'll tell you what, let's combine the like terms right here. Minus 4 minus 3 is minus 7. And I still have a minus 3x here. And on the other side I have all I have left on the other side is that 3x, because I already subtracted the 3y. Well, 1 minus 3y is negative 2y. Minus 4 minus 3 is minus 7. Minus 3x equals 3x. Well, get your 7, you add 7 to both sides and add 3x to both sides. We get minus 2y equals, adding 3x to both sides, I get 6x. And add 7 to both sides, I get plus 7. And then finally, just divide everything by negative 2. And I get y equals, well, it'll be 6x over a negative 2 plus 7 over a negative 2. Now, what does that give me? I can shrink that, simplify that a little bit. I get y equals 6 divided by negative 2 is negative 3, so it'll be negative 3x, and then plus 7 divided by negative 2, well, 7 divided by negative 2 is a negative 3 halves, so we could say minus 3.5. So what's the slope? Negative 3. What's the y-intercept? Negative 3.5, or the coordinate 0, comma, negative 3.5. And what is the x-intercept? Well, you could either put the stuff in Excel, and it will tell you what the x-intercept is, or put 0 in for y, and solve for x. If I solve that for x, I would maybe add 3x to both sides, get 3x equals negative 3.5, and then divide through by 3, and I get x equals negative 3.5 divided by 3. And whatever that is, it would be like a negative 1 point something. That would be what the x-intercept is. So I think it asks for all those things on that, but that's as hard as it goes right there on section 1.1.